So as Bob mentioned, I'm Walt Lindblom, which is neither one of the two names that you see up there. Back in 1997, we formed a little outfit called the NASA DTV Project, which turned into a program, and our job was to cat herd NASA television from analog to digital, and then hopefully on to HD. And we were supposed to disband about somewhere between 2002 and 2004, and we're still working, which is kind of nice. I like it anyway. A couple of years ago, we got changed into something fancy. We're now the NASA Imagery Experts Program. So, because we encompass streaming and regular video and still photography, so somebody decided we needed a fancy name. I'm just a video engineer. So, I work out of Huntsville, Alabama, Marshall Space Flight Center. We are technically responsible for NASA TV. We don't control what goes on it, just make sure it gets there. For those of you that may have been the last time that we did one of these meetings, we were out at Encompass Digital Media. That's where we do our uplinks. So I've got a trip there in the morning. I've made this into a 3-function trip. In addition to coming tonight, I had 2 other vendor meetings. So it's a pleasure to get back and to get a chance to talk to you again. We like doing this. We like getting out and doing these things. So I got a question. Who all was at the SMPTE Technical Convention? Okay, so some of this is going to be rerun, except I'm going to try to add a few pieces to it, because I talked to Rodney about what he and Dylan did. And it was kind of funny. Rodney said, "What are you going to do?" I said, "Your presentation," and he hands me, USB stick, says, "Here, go." So what we want to do, is talk to you a little bit about what we're doing with Project Artemis and imaging from the moon. For those of you guys that don't know, Artemis is the return to the moon program. It comes up in the video, so I'm not going to tell the story about how we got to the name. I have to go think about these things for just a second. But we've been tasked by the president to return to the moon by 2024. And our administrator, Mr. Bridenstine, has said we're taking the American public and the world with us. In other words, you're going to see all of this stuff as we go. A lot of people consider this picture to be one of the most significant images that has ever been made. It really, the moonrise that Apollo 8 took in 1968, to a lot of people, it started the environmental movement when you get right down to it. And it just encompasses so much stuff that it just hit people a certain way, realizing just how fragile our little planet was sitting out there. So, from the very beginnings of what we were doing with the space program, imagery's been a big deal. And in this picture, Mike Collins took this, and it represents everybody who currently lived at the time and everybody who had ever lived on the Earth, and everybody that was presently alive in there except for Michael Collins, because he was the guy behind the camera, in one image right there. So, imagery is a big thing. And it's absolutely amazing how much difference that it makes. I mean, the most famous television broadcast to date happened to be when we decided to go step out on the moon.
TV circuit breaker in. Houston, this Dale radio check. Dale, this is Houston, loud and clear. Break, Buzz, this is Houston, radio check and verify TV circuit breaker in. Got a verify TV circuit breaker in. All right, thank you. Verify. Roger, TV circuit breaker in. And verify clear. Roger. And we're getting a picture on the TV. Oh, yeah, a good picture, huh? There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail. Okay, Dale, we can see you coming down the ladder now. At 1 small step for man, 1 giant leap for mankind.
It's kind of interesting when you look at that caption up the top that says the most significant live television broadcast of all time was almost an afterthought. TV cameras weren't going to the moon. In 1967, somebody went, "What? No cameras?" There's no engineering requirement for it, which, by the way, is something we hear all the time. Until something breaks, by the way. Then they want to know where the pictures are. In 1967 is when the effort started to put a camera, live video cameras on Apollo. It was all going to be 16 millimeter film and still photography that would be brought back. Somebody had a little more forethought and said, no, that doesn't make any sense. We need to see this as it goes. So, you know, I'm sure you guys have heard most of the moon conspiracy theories that are out there. Can you imagine what it would have been if we didn't even have anything like that? And by the way, I'm pretty good friends with the guy that was hunting for the tape we could no longer find. And that's a whole nother story in itself. But, so Bruce McCandless, he was the Capcom for the moonwalk on Apollo 11. He actually became his own spacecraft. He was the only astronaut that we've ever had to fly untethered in space. Did that in 1984. And if you knew our mission management people, you'd understand they really couldn't stand that one. But it was one of those things, again, where you have an image that puts something out there that I mean, that's pretty Buck Rogers right there. You know, we get those pictures out and people are going, wow, no, that's just really cool stuff. And then we do selfies on Mars. Yeah. Now, we get a lot of comments about these pictures because the way this works is we've got a camera on an arm and it goes out and makes several pictures around, and then we go in and Photoshop it and Photoshop out the arm, but it's an actual picture and it's actually correct. That's Curiosity. The other two, Spirit and Opportunity, the rovers that we landed that were supposed to run 90 days, it went for what, 12 years? When they did a panorama, it was 75 separate images and it took a week to take one because they were filtered in 4 different wavelengths. It was all monochrome cameras and there were 1024 by 1024 imagers, and we take one, pan, well, we take 4, pan, take 1, 4, and it was 75 discrete images times 4 to do a panorama. So it's a little bit better on that, but we actually have people that think that can't be real because who took the picture? Yeah. And the other thing, it gets kind of interesting. Have you guys seen the animations that JPL puts together whenever we land one on Mars, and they usually called the 7 Minutes of Terror? We always get calls on that one wanting to know who shot that. We told them we got to make them a little less realistic, you know. And it is kind of interesting because we do things now pretty routinely from space, but it's amazing the number of times and events where, you know, all of a sudden you'll hear see what's going on and hear it. And it's not full bandwidth audio, which we're sending down, and they make the video look kind of crappy because that's coming from space. It can't look really good, can it? Now, in terms of photography and places to go, that's the best window in the world, actually out of the world. The cupola in the International Space Station is just a fantastic place. It actually doesn't have the most optically pure window. We do have one of those. It's a 24-inch window that's optically pure and about 98% transmission, even though it's about 2 inches thick. That's in the laboratory module. Gets uncovered, they shoot through it, they cover everything back up. But this is the place where the astronauts hang out, and I'll show you in a minute. It's where we do a lot of photography. But in the early days, it was really kind of interesting because we basically had to invent everything. Oh, well, your green laser is not real bright. So this was the camera that we had that was mounted on board the lunar module for Apollo 11. You know, it was all completely hand built. The only thing that was off the shelf with it was the imaging tube, and I'm sitting there racking my brain. I can't remember if it was an Image Orthicon or a Vidicon tube. Any of you space nuts out there remember that? Thank you. I was thinking that was the case. I didn't think we flew IOs. We still managed to kill one. Alan Bean picked the camera up with the iris opened up on it and pointed it at the sun while he was moving it out in Apollo 12, so we lost the video. So it gets kind of interesting. And then we had to be really unique in the way we did color TV. So anybody besides Bob understands or knows how we did color TV on the moon? Okay, the word's field sequential color. You know, in 1968, a state-of-the-art color TV camera was an RCA TK42. Camera head weighed 180 pounds. It had half a rack of electronics plus about, what, I think a 7 RU setup panel and an 85 conductor cable that looked more like a fire hose than a cable. But we could do small black and white cameras. You know. So what do? We go back to the 1951 accepted color television standard, field sequential color. We put a lens with a rotating color filter assembly in front of the tube, sync it up with a composite sync signal, and have it every time, every scan, we change it to a different color. So effectively off the moon, we ended up doing 10 frames per second RGB. And then had to put it all back together on the ground. I know how we do it digitally because I've worked with those systems. I still hadn't figured out how the guys did it in analog. But that's how we did color TV. We, by the way, did not retire that system until, officially retire it until 1993. We flew it on the shuttle until 92. So a lot of this stuff, by the way, if anybody tells you that NASA spends a lot of money, you know, just when I was telling some guys when we were eating supper, during Apollo days, NASA had 4% of the national budget for a couple of years. We now have 0.04% of the NASA national budget. A couple of years ago, I figured out in 2016 that our annual budget would have run the Department of Defense for 7 days and 12 hours. So we're not a big thing, but we do a lot of really cool stuff. But now we're doing some things. We're flying off-the-shelf cameras and components. And one of the things that when I came to work at NASA, you know, everybody had to invent this stuff. You know, the first data multiplexer that ever got built flew on the space shuttle. There were no commercial data multiplexers available. So the guys went out and invented it. And they were quite good at it. They had been doing it through Apollo. They said, this is our stuff. And we come in and say, what about off-the-shelf hardware? And they look at us like we're some kind of aliens. Well, you know, over the years, we've been getting there. When you see a broadcast, and we're going to show a little bit of the video that was part of the Los Angeles thing from the space station here in a little bit. But that's coming off of a non-modified Canon XF305 HD camcorder. It's going into an AVN 443, and I can't remember who makes it, the manufacturer. Encoder, card encoder that's in an enclosure. We've had a half a dozen of those things up for almost 10 years now and hadn't lost one yet. Cameras are a different story. We're going to talk about that in a minute. But we're really big on photography on space. That's Don Pettit. Don Pettit is the most prolific photographer that has ever flown in the history of human spaceflight. And you know, realize too that he's missing one camera because something had to take it. I don't know, unless somebody did it with an iPhone. Don was kind of interesting because back in the days when we had a whooping 50 megabit downlink from space, he filled up every bit of removable media we had for every single camera we had on board. And they said, Don, you're going to have to go edit your stuff and get rid of the bad ones. And he went, no, I can't do that. So eventually he had to, because we had to free up some memory space, but we were fighting, you know, we were working for bandwidth. Don hasn't flown again since we've upgraded. We now have a 500 megabit downlink, mostly thanks to him now. But we are doing that a whole lot more now. We're getting stuff down. Although the question is whether we get Don again. So we end up with a lot of really neat stuff. If I could hit the right button, I'd be dangerous. Thanks to an agreement between Red Digital Cinema and NASA, we've had an 8K camera up. Well, originally this was a 6K. We had a 6K Red up. That got replaced by an 8K camera. And we have gotten some absolutely tremendous images from that. That is, once we got the astronauts to figure out how critical focus was. By the way, you guys remember in the early days of HD, the first cameras that showed up didn't have focus controls for the camera operators because they didn't think they could do it. It would have to be done at the shading station. Well, I think in some cases with our astronauts, that would be kind of important. But when we bought our first high def camera, we needed to get NASA video to show to the upper management folks about what we could do. So I would send the camera out and I would send an email. Here's some things you need to understand. Number one, focus is critical. Number two, it's got something, 2 filter wheels, yada, yada, yada. Number three, focus is critical. Number four, number five, focus is critical. I had that in there 4 times in the emails. Without exception, the first day, the shooter would go out, go, man, the peaking on that viewfinder is so high, it hurts, turn it all the way down and then shoot everything out of focus. Well, if you think HD is bad, go shoot 4K. And especially with a large format camera. So it's taken some education, but you know, the longer we go, the better the astronauts get, and they shoot some absolutely tremendous stuff. Although what we're about to play you didn't actually come from that, but we get some images of stuff now that looks like this. Want to let thunderstorms in time lapse?
idea what city that is?
No, I don't. Sorry, Jack.
It's Florida. I learned that from Rodney's presentation.
Ah, okay. So the space station is really a great lab for testing and flying all kinds of different cameras. Up there on the top left was the Canon camera that was used for the last IMAX space movie. The one that's on the top middle is a 360 camera that we dealt with. Exactly what that is on the top right, I'm not quite sure what all that was supposed to be, but Don did some experiments that were that. And then we've got AstroBee that's down there in the bottom left, which is a free flyer camera system. So it actually flies around autonomously. We program it to go look at certain things and to be able to do things. The astronauts can voice command it. It's a pretty slick little system that it got. But the fun thing is that we really have been able to put a lot of different cameras on board and try different things. Sometimes you don't know what's going to happen. You know, there was a big question and we debated what would happen with the GoPro forever, and then we found out the Russians had taken them on EVAs about 5 times already. They won't last more than about an hour before they overheat, but you know, they got some pretty cool stuff. So we even modified a Nikon D4 to be an HD camera and a still camera sitting outside the space station. This was kind of an interesting project because the video guys, namely Rodney and I, argued against it and said you ought to put a video camera out. And I think the guys won in the end because what they did was pretty slick. Because now we're getting really good high resolution stills while we're getting live HD. So I don't know if you guys remember, but the last big hurricane, we just happened to have flyovers every morning during the morning news cycle. And if you saw any of that video, it was coming off the D4. But what we did is, you can see it on this picture on the far right. So this thing's it's not really pointing out too much. Okay. The little white circular thing is a Wi-Fi antenna. We're doing this completely by Wi-Fi. We encode out at the camera. We're bringing an 8 megabit signal in, Wi-Fi into the station, and then sending that down. It's mounted directly to another video camera assembly. We had a light that was there that we weren't using, so we pulled the light off, used the power for the light, plugged that up, and then literally bolted it right up next to it. It's field replaceable. The astronauts can replace them when they get too much radiation damage. And they're actually, we understand they're not that hard to do. Now we got a little inspirational video because when we talk about imaging and that kind of stuff, so here's something that we think you'll really enjoy.
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis, goddess of the moon.
We are returning to the moon.
As a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
Earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
we go for all of America.
We go. We go as the Artemis generation.
We go.
So Artemis, let's go back to the moon. We got a few challenges ahead of us. So to give you a little, a quick primer on that, what we're going to do with Artemis first is we're going to fly a thing called Gateway. And Gateway is going to be a lunar space station. It's going to be, I've heard the term rectilinear orbit, and I'm really not quite sure what that means, so don't quiz me on that part. But the way the orbit's going to be set up, it takes about 7 days for it to make a complete orbit. So it's going to go way up, come back around, and come on the close part. The good part is it never gets out of touch with the Earth. So we'll always be able to communicate to it. So Gateway is going to have a small pressurized crew cabin. So we'll have that up there. We'll also have this unit. The first thing it'll fly is called the power and propulsion element. So the PP&E will fly, or PPE will fly rather. Let me get that straight. And then we'll put the module up, crew module up, and then we'll start looking at what else we have to land on the moon. Now that's going to stay there. It'll probably be inhabited about 40 days a year when we're doing missions. So what we'll do is we'll fly a lander up, and that's what's attached to the left-hand side, the human landing system. And then on the back end of it is the Orion spacecraft, which we've already done one mission with, unmanned mission test flight a couple of years ago. So that's what's going to be in orbit around the moon. So we'll fly probably 4, maybe 5 people up to the gateway. 2 will take the human lander system down, and they'll stay on the first mission for a minimum of a week. May stay 2 weeks, depends upon what goes on. But we have this kind of issue since we've got this orbit that only comes close once a week, and our landing and takeoff times are pretty well set by what we're going to do with Gateway. So that's what gets us started. Now, the interesting thing is, I don't know how many of you folks keep up with the NASA stuff of what we do, what we refer to as commercial crew or commercial resupply, where we've essentially turned that over to SpaceX. I'm going to get this wrong if I go through it the wrong way, but SpaceX, Northrop Grumman. Is that it right now? Not yet. Not in terms of resupply missions. We've been flying commercial resupply, so we pay them to do it however they want to get the stuff up there. We're sort of doing the same thing with commercial crew. And commercial crew is that both SpaceX and Boeing have developed their own spacecraft, and we are just hiring them to take crews up back and forth from the space station and back. So we're doing kind of the same thing in the Artemis world. So the PPE was pretty well designed by a study that got done, so that one got turned around pretty quick. The logistics in the small pressurized module basically said, we want that, you guys tell us what you got. We're doing the same thing with HLS, with the human lander system. So the intent is that we think there's enough stuff going on in industry right now that they will come back with the ideas and the ways to do this without us having to go through these super long design efforts and then turn all the information over. So far, it looks like it's pretty much happening. But it's a really challenging environment. We get some real extremes in heat and cold. If you are out of the sun when you're in that orbit, it goes down to, and Bob, correct me if I'm wrong if I don't say that right, 2.7 degrees Kelvin. It's on the notes for the slide, and I don't have that. If you're in shadow up there, you're at 2.7 degrees Kelvin, 2.7 degrees away from absolute zero. But if you get on the sun side, you're like 260 degrees Fahrenheit. So we've got that we got to deal with. We got vacuum we got to deal with. We have radiation issues we got to deal with, because low Earth orbit is a lot better radiation scenario than being around the moon. Get hit by a lot more stuff. And lunar dust. There's a big difference between dust on the Earth or soil on the Earth and soil on the moon. Moon soil is called regolith, whereas most dust particles, if you look at them under a microscope, are pretty rounded. The stuff from the moon is very jagged. It's never had the erosion done to it that we've had with water doing it to our soil. It gets into everything, and it is a first-class mess. And as far as radiation damage is concerned, let's see, yep, I'm gonna have to turn that down. See how well we can see this. Looks like more on the, okay, if you look on the TVs or on the screen, you can see a lot of red dots on there. Those are not stars. That's 2 years worth of radiation damage to a red digital cinema camera, which, by the way, is really good. We've had one camera that we flew that did 1,500 pixels in 2 weeks. We also flew, if you guys remember, Panasonic had a 3D-A1 3D camera that they kind of threw together in a big hurry back in the last 3D rage. We flew one of those for over 2 years, never saw the first bad pixel. Got it back on the ground, turned all the pixel correction off, had less than 600 bad pixels across all 6 sensors. So it makes a difference. The Canon XF305s, they typically last about 8 to 12 months. So if you look in that picture, if you see little bright spots, not so bad when you've got a fairly well lit scene, but look at the astronaut's face. All those little places that we've got a circle around are bad pixels. Now, a couple of things can happen when you get ionizing radiation damage. What it typically hurts or what it destroys is the transistor relative to the photosite. Usually doesn't hurt the photosite so much. And the transistor now is going to do one of two things. It's either going to quit entirely or it's going to go wide open. When they quit entirely, we don't notice them too much. When they go wide open, we get bright spots. Suni Williams, one of our astronauts, did a tour of the space station a few years ago. She was very careful to wear the same clothes throughout the entire tour because it took about 2 weeks to shoot it. However, they shot it with about 3 different cameras, and we can tell because of the difference of the number of spots in them. One camera was a new one, it looked great. One camera was, been up there a little bit, wasn't too bad. One of them looked like she was flying around in a snowstorm. So that's just one of the problems we try to deal with. We've also found that trying to harden an HD or a UHD camera is just not cost effective. It is literally cheaper for us on the space station to run them for 8 to 12 months, toss them in a progress resupply vehicle, let them burn up, and just send some new ones up. So, and like I said, the neat part is the encoders have never failed. They'll go stupid because they'll unplug them and leave them powered up. And if you guys know, with encoders without video on them, every once in a while, they'll just say, I'm done. Pull the plug, plug them back up. They have never failed to come back up. So this is the interesting part of the pitch in LA, which is, I know you guys are not typically vendors, but we're looking for ideas from everywhere we can get it. You know, we need some help. What are we going to do? You know, we've kind of figured out that on the Lunar Gateway that trying to put a pan tilt unit out there, particularly if it's got to stay on the shadow side, is not going to work too well. I can tell you, you know, we fought some stuff a couple of years ago. One of the things we did after the Columbia mission was we put a camera system on an airplane that flew at 65,000 feet, minus 100 degrees Fahrenheit. To say there were some challenges was the understatement of the year, and that's nothing compared to going to 2.7 Kelvin. So we figured out moving parts are probably not going to work. So one of the ideas is use a VR type camera. Another one is to use a very high resolution camera, say put an 8K camera out with a wide angle lens and window out of it. If you do an 8K camera and do a 1080p slice out of it, it's effectively the same difference as a 16x zoom. If we do 720, we get a 36x zoom out of it. So we're looking at different things and different ideas, and we are interested in what people will want to do. And then one of the other fun ones, how are we going to get that view from the moon? And especially, how can we get it without having an astronaut run the camera out there first? How many people were alive when Apollo 11 landed that are in this room? How many remember it? Let's put it that way. Okay. So what you remember was that video of Neil coming down the steps, and then you didn't see anything for a little bit, and that was because he got the camera out and put it on a tripod and a cable and got it out, and then you got to see more of what was going on. We'd like to see the first steps. So what would work on that? Yeah, there's some pretty slick little robotic ball cameras out there now that have got stabilizers in them. So one of the things we've been talking about is if we Wi-Fi'd this back to the HLS, is that maybe we could do that. They could open the hatch and just throw it out. And honestly, if it lasted an hour, it'd probably be enough. Yeah. So, you know, it's one of the things that we're slowly getting some people to understand is that in a lot of this stuff, it's the first couple of images you make. It's not necessarily working the entire time. That's the biggest thing that we got to deal with. So if we had something like that and we could prove that it would work for a couple of hours or even a day or two, would probably be more than we need. And have your hardened camera or whatever you're going to deal with from that standpoint to put on the tripod and get the other stuff. But just think how cool it would be that if we saw the first steps on the moon where we had a nice wide shot of it. Another thing too, you know, the demographics are changing. You know, how many folks do you know are cord cutters now that are young people? A lot. You know, what's the main form of getting stuff? Streaming video. Imagine what it would have been like in '69 if we'd had the internet and all that kind of stuff, if we could have followed the Apollo 11 mission online. Well, we're going to do that for Artemis. There'll be a full-time streaming presence that'll be out there. There'll be something going on from the mission 100% of the time. The question is when do we start it and how long does it run? But, you know, we can start to integrate a lot of these different pieces. How many people saw the Apollo 11 documentary that came out this past year? What was your prime source of information on that? Well, I'm sorry, prime source of data about what was going on beside the video, the film.
Talking to the director. Oh,
Yeah. It was, you were hearing the air-to-ground audio, mission control audio, and Walter Cronkite. Okay. So during Apollo days, what we had was we had a commentator, news commentator like a Walter Cronkite. And then you stuck somebody beside him. I think in Apollo 11, Wally Schirra sat there with him, and Wally Schirra interpreted the technical stuff and told everybody what was going on. We can put that stuff on screen now. As a matter of fact, we just did a test down at Kennedy Space Center a couple of weeks ago where, and this has been very, very hard to do because SpaceX is very closed. I'm just going to be nice about it, about what they want to let us have. But we are now getting telemetry from SpaceX, and we will be getting telemetry from Boeing when they fly CST-100, Starliner. And we will be displaying that as part of our video production feeds. So that kind of stuff is starting to catch up, and we're able to put that or get that and change it. And of course, everybody has a screwy format. But all this stuff is for us to get ready to go to Mars. I mean, that's the whole point of going to the moon. There's enough in terms of what we refer to as a Mars analog going to the moon. And also, Gateway is a great stepping off point. If you're going out of low Earth orbit, you got to get up to 25,500 miles an hour to get out. And if you're trying to do that with one large spacecraft, it's really tough to do. It takes a lot of rocket power. But you can put a lot of smaller payloads up on Gateway, assemble your rocket up there, and then take off from there. Escape velocity is a whole lot less, takes a lot less rocket, and it's a good place to work from. So that's part of the other thing of Gateway, is getting us ready to go to Mars. But Mars is in a whole other environment.
We are decelerating. Race mode under our parachute started at 150 meters per second.
Dynamics phase. Come back again with risk mode dynamics.
Risk mode is nominal. We're at 9 kilometers, 860 seconds. Solid range. That filter is converted with a velocity correction of 0.7 meters a second. It fires the ground to the radar. Now to 50 kilometers. Digital section has separated or found the ground due to reflectation as expected. We're using by the prime the Emily engine to separate power play. We're down to 90 meters per second at an altitude of 6.5 kilometers per second. Flight EDO, we got tweeter warnings. I didn't think that was low, so I should have director of communications at this time. We may have lost our way. We're down to 86 meters per second at an altitude of 4 kilometers per second. We've lost zones from Earth at this time. This is expected. We're continuing on Odyssey 20. Ground solution equals minus 10.8 meters, vertical velocity of minus 80. We are priming 8 meters of light start enabled, standing by for backshot separation.
Signal to Odyssey is still strong.
We are in power flight. We're at altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey is there.
Down to 50 meters per second. 500 meters altitude. Standing by for skytrain. Constant velocity accordion nominal. Altitude error 5.9 meters. We found a nice flat place. We're coming in ready for skytrain. Down to 10 meters per second. 40 meters altitude. Skytrain started. Descending at about 0.75 meters per second as expected. Expecting final petrol leak.
Signal to Odyssey remains strong.
Table it out to nominal. Yeah, you go home, configure stable. Yeah, stable. Your check is good.
You notice there is a little bit of image in there. You can see it a little better on the screens. Okay, so the interesting thing about that is that's all video that we put together after the fact. It came down a couple of days after a landing, synced it up with the audio track. And the really interesting thing is that every call out that you heard happened 9 minutes in the past. So when we got information, so, you know, we always do these animations. It's usually 7 minutes of terror in terms of getting to the surface of Mars. And it truly is for those guys. But the 7 minutes was already up. And it was on the ground either successfully or crashed before we got the first telemetry that 7 minutes started. In other words, 2 minutes after, when we started getting stuff, it had already been on the ground for 2 minutes, one way or the other. And then they tracked it down. One of the rover landings, I was out at JPL, and I was in the room where all the engineers that figured out how to do the smart stuff were shooting video. And one of the guys was there looking at a console, and he goes, well, this just happened. And then he waited, and 9 minutes later, we have confirmation it happened. And they all get excited, yeah. But you stop and think about it. Depending upon, Rick was saying that the live event with the space station out in LA was about a 10-second latency. I think it was about 5 seconds one way. You guys may remember in 2017, we did live UHD from the space station to NAB, 10 seconds one way. Now, a lot of that had to do with, and in this case too, with the LA, had to do with the fact that we were using cloud services to do that with. And I'm not knocking the cloud services. It's just that at this point in time, they haven't really figured out what real-time video looks like. So we get a lot of latency through that. We get enough as it stands, but we have to add a little bit more to make it fun. So there's a lot of challenges involved. One of the things we're working on right now is a sample return mission from coming from Mars. And what you have to realize is that all that stuff has to be able to work with us just saying go when you think it's right. So it gets really interesting and a lot of challenges. So what do we need help with? Figure out some way to minimize the effects of radiation. How do we get rid of this problem with the lunar dust? And that is, by the way, one of the biggest challenges that we've got with this. We introduced some new suits a couple of weeks ago. And one of the things that they're designed to do is to allow an astronaut to bend over, kneel down, which they could not do in Apollo. What they did, but they fell. But they have to have slip ring joints in them that won't get bound up by this stuff as they go through. And it is kind of interesting when Apollo 12 lunar module redocked back, Pete Conrad and Alan Bean had so much stuff in them that I can't remember the command module pilot. Dick Gordon wouldn't let them come in with their spacesuits on. He made them take their spacesuits off, come in naked, and then clean off the spacesuits and bring them back in. So just a lot of really stuff we got to work with. Autonomous operations. Now we got to have things that we can, like I said, if we have one of these ball cameras that we can work with, got to throw the thing out. It's got to be able to figure out what to do. So it's got to be a good bit of artificial intelligence built into that as well. How do we do pan, tilt, zoom capability with no moving parts? What are we doing on the lunar surface? And anything else you can think about from an imaging standpoint, because it's a big challenge. Now, the good part is, as I mentioned, that in 1967, somebody figured out that, oh, by the way, we don't have a live video camera coming from the moon, and we need to fix that. We've been in on the front end of Gateway, and we're pretty much getting in on the front end of the human lander system in terms of making sure that we got cameras on there. Rodney Grubbs, who was mentioned on the first part of this and is my NASA guy, he is the imaging lead for Gateway. And the mission managers and the program managers said right off the bat, we got to put cameras on this thing. Crazily enough, a lot of the engineers went, there's not a requirement. Sounded just like what we've always heard. But then, I will say smarter heads prevailed and said, well, what happens when something breaks and you can't see it? Yeah. But a lot of things that we have to deal with. So these links are here, and Bob says he's going to publish a PDF of this, which, by the way, won't have the videos in it. I'm sorry. But there are some places there where you can go take a look at things and pull some video down and look at those. and you're more than welcome to. And the authors of this paper, Rodney Grubbs and Dylan Mathis, can be reached. I would recommend Rodney because I work for him. So, but no, seriously, he is the imaging lead for Gateway and should be for HLS as we get into that. And it's really neat that for once imaging is on the front end of one of these things and not on the back end. And with that, Bob's going to play a little bit of video from what we did out there with the space station.
We have a surprise for you. We've been kind of holding out to surprise all of you.
Station, this is SMPTE. How do you hear?
A little bit of latency.
Welcome aboard the International Space Station.
So, good morning. This is Dylan Mathis with Rodney Grubbs from Marshall. We just wanted to take a little bit of your time to talk about imagery from the space station. First off, I'd like to congratulate you all on a spectacular EVA last week. Outstanding job. But our first question starting out is, what images from the space program inspired you when you were younger?
I'm not sure what that was all about.
Well, one of the images that is most striking in my mind is the iconic Earthrise photo that Bill Anders took on the Apollo 8 mission. And that was a very important image to me because, first of all, it really was quite pivotal for several reasons in terms of shaping the environmental movement and also in making people start to think about our significance within the solar system and the universe, and really how insignificant we are as humans and on our planet Earth, and also how fragile the planet Earth was, how thin that boundary of the atmosphere is, how we really needed to protect it, and how we really do only have this one true home. And that image really did put that thought into people's minds, some of which for the first time, to help start that environmental movement. People start thinking about the planet and conservation in general and all of the resources back on Earth that we really need to make sure that we protect.
And for me, something that stands out are the IMAX films of my childhood. So things like The Dream is Alive, Hail Columbia. I grew up in a small town, we didn't have an IMAX theater or anything. So I actually saw my first IMAX film when I went to space camp, and it completely blew my mind, and I was enthralled with it. Just the fact that, you know, with the wraparound screen, you felt completely immersed. And every year that I went back to space camp, I saw the same movies, but I never got tired of them.
In this recent past here on the ISS, we've done a number of spacewalks, as you know, very high profile one last week, and one of the iconic images that people often associate with NASA is the picture of Bruce McCandless and the MMU, the Manned Maneuvering Unit, our archaic nomenclature now, but nevertheless a picture of him in that, what otherwise I think commonly people would assume is a jetpack, and that is a really interesting and ironic image because it was actually one of the few times that spacewalks was conducted untethered, because actually when we do spacewalk now, we're always tethered, and so that it has become an iconic image of spacewalking, what it means to be an astronaut, to be out there alone and unafraid in a spacesuit with a jetpack on.
What can we do in an age where so many...
Oh.
Yeah, that was his line.
Okay. Yeah. Man, I hate it when celluloid does that. To tell you a little bit about how we did that one, that was kind of interesting because we do a lot of live events from station. Last year was a year of education. I was estimating a little while ago, I think we did in excess of 200 live events with schools last year. Now, I can remember a time when we did anything live from space, we sent a team of technicians out from JSC to go handle this stuff. Just saying, okay, we're going to schedule it was a big deal from that standpoint. Now we're doing this stuff with schools where we bring the video down and we Skype it to the school. We pull the audio back from Skype. We don't send video back up. They don't get to see, they just get to hear. And we do these things at the drop of a hat. And we were talking about it the other day. We typically do 20 to 25 live events from the station every single month. And you stop and think about that for a minute and you just think of it as routine. And all of a sudden you realize those people are whizzing around a couple hundred miles up at 17,500 miles an hour. And we're just doing live shots. And they are. We do live shots from space all the time. But on this one, we had to get the video out to SMPTE. It was SMPTE. It had to look a lot better than it was going to look if we were going to do it as a Skype call, because we weren't going to put that up on a big screen. Amazon Web Services partnered with us on this. So we put an encoder in at JSC. So we did go through an encode and a decode cycle, getting it down to Earth and then to put it into their system. From there, it went into their distribution package of stuff, and then it ended up in LA, and then we decoded it and stuck stuff out. Did a phone line return back for the questions or for the comments that came back. Rodney Grubbs, when you heard him, one of the things you have to realize is that he had flown all night long to get there in time from Germany. We had a standards meeting with the other space agencies that we had done that week. I stayed in Germany, by the way. So we had all of that set up, but in case we had a problem, which we did, because Amazon said, oh, or it was the elemental encoder that we had at JSC, and they went, you've got the old one, you need the new one. We put it in, and the NASA firewalls went, wait, that's a different MAC address, and shut it completely down. We already had a plan B. NASA has a pretty extensive broadcast video network. You guys know we uplink in Encompass, so we got to get all this stuff to Encompass, and my contract runs the network, so that makes it a little bit easier to deal with. We also run all the firewalls, which makes it a little bit easier to get an exception, because we should have started that about 2 weeks earlier, but we managed to make it. But our backup plan was send the video to Encompass, let them put it on Amazon at that point in time on AWS, and they get it out there. So we had both paths ready and available, tested and checked. You know, it's that NASA redundancy thing. The other thing we don't like too is, most of you guys know I work for SAIC, not directly for NASA, although for all these years I've had a NASA phone number, a NASA email address, and when the contract changes, sometimes I don't remember who I work for, so I might as well be. But you know, we don't like our NASA customers to be embarrassed. But for those of you who are out there, the reason why it was a surprise is that we went up until the day before not knowing whether or not we'd actually be able to pull the event off with the schedules they were running on the space station. They've been replacing batteries like crazy. They've been doing a lot of EVAs, and it was the commander's call whether or not they supported this event. And if he thought his crew was a little bit too tired, he was going to pull the plug. So the day before, after we had everything tested, checked, and done, they went, okay, we're going to do it. Whew. Yeah. So that's the reason why everybody got excited. Nobody knew that they were going to talk to the space station that day. And it's a really neat thing to have happen if you ever get a chance to do one of those. So other things that we get into, not as exciting as space station, but this past summer, on July 19th, because we figured July 20th we weren't going to get any astronauts, NASA did a 2-hour video production. It was referred to or called Giant Leaps, Past and Future. We had several sites across the US. It was a 2-hour show. It was simulcast on Science Channel, and I hope nobody watched it there. Did anybody try? Good, because when it was time to do a commercial break, they did a commercial break. They didn't delay us. They didn't do anything else. They just cut away, did 3 minutes of commercial, and then cut right back in wherever it was. It was terrible. So, but anyway, we had multiple live locations across the country. We used a mix. Now, keep in mind, you know, some of you guys that do this stuff for a living, you know, you don't think twice about doing 3 or 4 live places in a given thing. But for NASA, that's a pretty big deal. But we used a mix of satellite trucks. We used our network. It's called MCDTV, multi-channel digital television, and some real-time streaming to get things from the different locations. We sent everything to Kennedy Space Center to be switched into the master program. It was similar to what we did for the Eclipse, where we sent all the video to Charleston and switched the entire show there. The difference being, though, is that when we did the Eclipse, when the site was finished, when totality had gone past that, we turned them off. We didn't want to see them anymore. We didn't care. You know? That wasn't the case with this one. Everybody was interactive for almost the entire show. So these are the locations. We were at the Museum of Flight in Seattle, Washington, because in July, that's where the Apollo 11 command module was. We were at the Armstrong Air and Space Museum in Wapakoneta, Ohio. Please say that 3 times fast. We had set up at the U.S. Space and Rocket Center, emphasizing the Saturn V. We were at Space Center Houston, which is the big museum that they've got outside of Johnson Space Center. We were set up in the Apollo Mission Control Room. And by the way, if you get the opportunity, if you go to Houston, take the tour, go look at the Apollo, and I'm going to give you the term. It's the Mission Operations Control Room, so you want to go see the MOCR, okay? It has been completely restored to exactly what it looked like in 1969, and not with taxpayer money. Space Center Houston headed it up, came up with $5 million to pull all that stuff off. It is amazing. There were things that happened. It had an embossed vinyl wallpaper. They had from the records, they knew who made it. They went to the manufacturer and they went, we haven't made that since the 60s. And some guy that was there went, wait a minute, I'll be back in a little bit. Comes back a little bit later and goes, here's the roller. We'll make a special run just for you guys. They weren't quite sure what color the carpet was. It had been just that discolored. They pulled a piece around. There was a wood surround that was on the thing. They pulled it up and lo and behold was some original carpet. It didn't have any stains on it, no dirt. They took it back to the manufacturer and they said, well, we don't make that anymore either, but if we take this and put some white threads in it in a couple of places, it'll look just like it and it'll last forever. So it is restored back to even to the point where the ashtrays, they got all the photographs out. The ashtrays are out, although I got to laugh about it. There's no ashes in them and no cigarette butts. They're there in the pictures, but they didn't put them in. But they were very meticulous about it. And in fact, we thought we were going to be in the area they refer to as the pit, which is between the last console and the screens. By the way, have you guys ever dealt with Ida-4 projectors? Yeah. They're still there. They're not using them. They put laser projectors in, but they left the projectors in place for. Actually, they pulled them out and put them back up. They've been replaced. The Apollo MOCR got used for shuttle until, let's see, the last flight it did was STS-26, which was Discovery, which was the flight after Challenger. And then they moved to a new set of mission operation control rooms. They did sort of a half-hearted effort to restore it back to the way it was then, and then left it. But basically, if you had access to the building, which is a very closed off building, by the way, but if you had access to the building, you could get in there. But they had it completely redone, and that was its opening time, and we got to go in and do video, and it was pretty slick. We had 2 live locations at Kennedy Space Center. We had one that was overlooking the pads. We had another location which really hosted the show out of, which was in their Saturn V building down there. So that's what it looked like to put it all together. So we used a big combination of things that we had. So tried to get all the sources on the right, but we had 2 satellite trucks of all things at the Space and Rocket Center, U.S. Space and Rocket Center, which got referred to, you heard the astronaut talking about going to space camp. Well, that's at our place. We don't have a video circuit from there back to our center. So we had to put a satellite truck in. We put another one in Wapakoneta. And then in JSC, Houston, we did the Apollo MOCR. We just ran that through some fiber lines back to get it to an encoder and put it on our network and got it down to KSC that way. We had, I did mention we had 2 locations in DC. One was on the National Mall. The other was in the National Air and Space Museum. So how many people are familiar with Verizon AVOC service? Yeah. Anybody know where a route map is for that? It's the most interesting thing. AVOC is the Audio Video Operations Control Center that Verizon runs in DC, and you never know exactly where they can get to until you ask them. I believe you're right. But they're very handy in the DC area, but they're even connected all the way down to Encompass down here. They can pick up AVOC feeds for us if we need them to do that. So we got an AVOC circuit put in. We ran that to Goddard because we needed to keep stuff free from NASA headquarters. Ran it through our network. Air and Space Museum, we do have a direct fiber connect baseband HD back to NASA headquarters. So we brought that one back, encoded it, and sent it down that way. We also kept the feed up available for the White House because up until the last minute, there was a good chance that the president was going to want to play and he was going to jump in when he wanted to. So we had to be ready for him. We did 3 streaming systems with tear deck encoders. We did the Museum of Flight in Washington with that. We also did that at Space Center Houston, and we had a roving camera in the KSC Saturn V building that was doing that. So all of those were running to the tear deck core and then coming in. So, and then on the left side, you can see the KSC portion of that, which all came in baseband, and they brought all the cameras back individually into one switcher down at KSC. And then the output side was pretty normal. We sent 2 feeds out, sent it to Encompass, and they stuck it out on the satellite on both channels, and we also hit our streaming encoders. Some of the fun part, though, was trying to figure out how do we do IFB with all this mess. And that's kind of what it looked like. And originally, I wanted to do all the IFB out of Houston because the Houston Audio Control Room does more of this stuff. The last time I counted, they had 16 hybrids sitting in place. And I thought, we've got to do it out of there because they're the only ones that have enough stuff to do it. And the longer it went, the more I went, that doesn't make any sense. Because particularly with these tear decks, we were going to have to feed the audio back into them. So we were going to have to set up a bunch of audio paths. So about the time I thought, I need to call the Kennedy guys and see if they can handle that, my phone rings and it's the audio guy and the chief engineer down at Kennedy going, we think we can do all the mix minuses. And I went, go. It's all you, brother. Because on the tear deck stuff, you feed the IFB line back into the decoder and it comes back out. We did find latency on that. It's a big issue. So we're having lots of fun with that stuff. So we had multiple IFBs per site, but what we did was we gave them 1 feed and told everybody they were on their own to get it into the ear of everybody that needed it. So pretty extensive from that standpoint. We also had, and this is something that we need to do a little more work on, and I'm willing to take any suggestions from anybody. The way we set up intercom is Goddard Space Flight Center runs all the voice comm circuit stuff that we do. We just had everybody dialing into them. They were putting everybody into a common bridge on a loop that goes across NASA that Encompass hears also. We have never had that work right. So it worked well enough. But one of the things that we found is that we had one location that screwed up what was going on. One of the things I did with all the streaming locations was I gave them a JK Audio belt pack that would Bluetooth into the phone and had an intercom headset. I was trying to force them into using a push-to-talk switch. You can do that, and that works unless you put the switch in the wrong position on the JK Audio widget, in which case it feeds everything right back out of it and causes this great big echo loop. That happened to us in Seattle, and nobody could isolate it. So we ended up having all kinds of fun trying to figure out how to talk without hearing an echo. But most of the sites were doing a package of stuff that they were going to do, interviews, whatever it was, and then they were tossing back, and then if they had questions, they'd go back. The IFB worked like a champ, so us production folks, and I counted me as one of them because I went to Houston for this event. I wanted to go see the Apollo Moker, so we took our fly pack system down there for that. But you know, we didn't have to have that much comm. All we had to know was they're coming back. Now, I didn't get a lot of pictures from a lot of places. I asked for them, but this is kind of cool. This is our TD and our producer in Houston. We had our fly pack system set up in the control room. And you can see that's the producer and the floor director and the folks who are getting ready in the Apollo Moker. And they, by the way, run the old video continuously on that stuff. It's a really slick presentation. Since the pointer's not giving me too much stuff, I can't see it. But we got Charlie Duke and Gene Krantz. Gene Krantz was the lead flight director for Apollo 11, was the guy that was on console when they landed. Charlie Duke was the Capcom when they landed. So if you remember the words, you got a bunch of guys about to turn blue down here, that's Charlie. Really nice guy. When Mr. Krantz showed up and walked into the conference room, which was across the hall from the Moker, he looked around, and as you kind of heard from that video, his voice was kind of gravelly. He looked around at what we had set up, and we had covered this long conference table down both sides. And he looks at it and he goes, that'd make a fine flight control room. And then comes around and fist bumps all of us, and we're like, well, that's it, we're done. Life is grand. So that's the two of them working out the stuff with our TD and our floor director in terms of what they were going to do. I think I got one of my cameras in the background. And what was kind of interesting is that if you see behind them, that's the gallery room, the viewing room that they had for the Apollo Mission Control Room. if you go as a tourist, that's where you go. You don't get to come inside. I hate to tell you that. But it was really funny seeing those two living legends standing there and all the people back there going. You know, some of the people, hang on just a second, some of the people were kind of, you know, well, we're going to interrupt their view and that's going to be terrible. And that's going, not with those two guys sitting there, everybody, man, the cameras were like crazy. So you have a comment?
Well, I think I heard a story that Gene Kranz walked in and said something about his telephone's missing or there's supposed to be a telephone.
Oh yeah, he did that several times.
Like I had to redo the room.
Yeah, there were, the lady that was in charge of the reconstructions, the historian, and that's the fun part about getting old. I can't remember her name off the top of my head. When we first went down there to decide to see what we wanted to do down there, I think it was March. And we walked out with the idea that if we even messed up a piece of carpet, the least little bit, I mean, like, you know, stepped on it the wrong way, that the whips were coming out and we were all going to pay dearly. Turned out to be our best ally. She was fantastic in helping us get set up and doing things. And whatever the restrictions were, it's like, thou shalt not use any gaffer's tape. So we used Velcro strips for all the cables to hold stuff down, you know, or routed them out of the path so we didn't have to do anything. I had to cross a hallway to do that. That had, by the way, there's some really neat gaffer's tape that's yellow and black with a central part on it that doesn't have any adhesive for your cables. But you can make one heck of a warning barrier of that stuff. The safety guys came along, thought they were going to gig us and looked at it and went, we wish everybody would do this. But yeah, Mr. Kranz came in several times and looked at it and went, that's not right. Or most of the pictures were in black and white and you go, that wasn't a red phone, that was a green phone. The other one, he sat down at his console and all the lights light up. And he looks at his console and he's got this really concerned look on his face. And he looks up, I just about said the lady's name, and she goes, I don't know what this is. She goes, what do you mean? It's your console. He goes, blue lights. These are all blue lights. I didn't have any blue lights. Sure enough, they were all green and red. So yeah, he was on top of that every step of the way. So anyway, we've been having a little fun. It's an interesting thing. One thing, I'm not going to pull it up. I mean, we're right now in the process of building up a UHD fly pack. I've told the story to a couple of you guys, but about how many of you know what the James Webb Space Telescope is? Yeah, that's the one that's going to make Hubble look like the starter kit. It's going to be 1 million miles away when it gets launched and gets out of here. And it's getting launched so far away. It's a joint project. So the European Space Agency is going to launch it on an Ariane 5 rocket out of French Guiana. So Rodney, my NASA guy, goes, what would it take to take the fly pack down there and shoot the launch? And I just started laughing. And he goes, what are you laughing at? And he says, that's not funny. And I said, oh yeah, it's hilarious. I said, you do understand that shipping directly into there is the same difference as shipping essentially into a third world country. Our church and some other churches raised $15,000 to send a tractor to a missionary, and the missionary got a box. I said, the only way we can assure our stuff's going to make it in one piece, and even because I've done Russia and gone to Baikonur, and it was hand carry almost everything that we didn't ship directly to our people. Well, actually from Moscow to Baikonur, it was hand carry. I said, we'll either have to ship this stuff to Europe and have ESA ship it in as part of their stuff, or we've got to be able to hand carry it. Our fly pack, which I laughingly use that word for this system, 1,600 pounds on 3 pallets. 2007. I mean, it was the best you could do. So we've been working on a new one, and I got most of the pieces this past week, and it'll be a UHD fly pack. It's going to go in 6 cases. We can check as airline baggage. Well, here's the fun part. After we went through all that stuff and I went through the design exercise, they decided NASA wasn't going to do live video down there. But you know what everybody said? Build it anyway. No, we think there's a lot of usage in it. We built the first one in 2007, did one upgrade to it. All total, we put about $330K into it. 2 years ago, I figured out we'd save $3.5 million in rental costs. Now, the way I calculated that was like a rental house would, day it left till the day it got back. And a lot of times it went and stayed for a long time. But if you're a rental house, you'd be charging for that. So we think, well, we know it's going to be the only available UHD production package available for a while that's not built in. And in terms of the built-ins, we're really only going to probably have 1, maybe 2 across the agency in the next 2 or 3 years. So this gives us the ability to go out, capture an event in UHD, distribute it in HD, and then have the other stuff as part of the permanent record. So that's a little bit of our world.
What's the latency? If you were to subtract out all the processing, what was the base latency from Earth to ISS?
Almost exactly one satellite hop. Because everything that we do going to ISS goes through the tracking data and relay satellite system, TDRS system. So all that's in geostationary orbit. So we uplink out of White Sands. There's essentially no real latency from Houston to White Sands, and then go up and then come back down. So, station, I say only, 220 miles up or so. So it's not that much different from making the full hop. So about a quarter of a second. Yes.
When you talk about putting real-time telemetry and stuff on the websites, how much of that's ITAR scrub?
Okay.
There's a lot of data that's flying around.
Bob, I'm going to remember to repeat the question. So the question was, if we put telemetry data up on the screen, how much of that is ITAR? That's International Trafficking in Arms Regulation is what ITAR stands for you guys. Did I do that right? I think so. Close enough to count. Anyway, there's a whole lot of regulations that we have to deal with about not giving away information that potential enemies could use against us. The answer is that we aren't putting anything out there that hasn't already been approved to be let go. So, we never do anything like, for example, fuel tank pressures. That would be a real key factor for something that somebody might want to know what's running into. But in terms of altitude, velocity, what angles we're going at, most of that stuff's pretty easy to decipher one way or the other anyway. So we've gone through the full ITAR scrub on all of that stuff. And in fact, SpaceX and Delta, they already decided what they were going to, SpaceX and Boeing have already decided what they're going to let us have. And then we took that to the ITAR folks and said, well, you let us put this out. So we've already scrubbed that. I'll get to you guys.
Oh, on the Wi-Fi you were showing, what does that interconnect into?
We have a Wi-Fi network on board the station. We have, it's called JSL, Joint Station LAN. The International Space Station did not launch with IP. IP wasn't in a position to go into space when we started putting modules up. So we've done some pretty major upgrades on the avionics, and one of which basically put an entire IP network on board the station. As part of that, we put in Wi-Fi nodes. So what that's transmitting to is a Wi-Fi node inside the hull. So, yes.
So when that guy ran out of memory space on his memory cards, why didn't you just send up a whole ton of memory cards on the next resupply?
Question was, why didn't we just send up a whole bunch of new memory cards when Don Pettit filled up all the ones he had? Do the words $10,000 to $15,000 a pound upmass mean anything to you? Yeah, they are. Every once in a while, we'll have an under-prescribed mission, and we've managed, matter of fact, that's how we got the first red up, was that the Japanese were going to fly an ATV up. Is that ATV? HTV. ATV is the European Space Agency one. But they were flying an HTV up that had about 400 pounds of extra capacity in it they didn't need, so we shipped the red over to Japan and let them send it up. Most of the time, though, we are trying to figure out what they can take off to put something more important on. And honestly, how many of you guys are still photographers? Still photographers, okay? How many of you guys are shooting raw images? How many of you keep all of your images? Why? By the way, you see my hand still up, it's just absolutely insane. But that's, when we do that, and I'm probably, I don't know if you guys are as bad as me, I shoot a JPEG at the same time and I keep all of them. I don't know why I do that, but I do. But that's kind of the way he was on that. And then, and the other thing too is I got kind of tickled when you were listening to the Mars landing. Did you hear the camera going off in the background? That was one Mr. Bill Ingalls, chief photographer for NASA. I actually have seen a video of the control room because I was painting cameras when that landing happened out at JPL. And it was really funny because every time we took a shot, Bill walked into it. It's what still photographers are designed to do, by the way, is get in front of video cameras. But he shot all night long like that camera was running, like you heard it. He probably put 5,000 or 6,000 images to cards that night. You know, Pettit shoots like that too. We all like to play like we're National Geographic photographers, right? So, you know, that's one of the things. But that's the reason why we didn't just fly stuff up, is at the time we were running short on space and time and things, and it was just finally like, okay, Don, you know, get rid of the duplicates, throw away the bad ones, and that knocked it down to about a third of what the overall total data was that he had sitting there. Yes, sir.
I was just curious, you mentioned SpaceX and Boeing as far as the resupply missions. Where is Blue Origin in all of this? I know
Okay.
it's not the PR salesman that Elon Musk is.
Yeah, that's true. Well, okay, so right now the resupply missions that are flying out of the U.S. are Boeing's not flying resupply missions; they're about to fly commercial crew. So we got the Cygnus, which was orbital ATK, is now Northrop Grumman, and then we got SpaceX that are flying those. Blue Origin is in the mix, but I'm not really sure exactly where. One thing I can tell you that Blue Origin is doing is they're starting to build rocket motors and big ones. The replacement for the Atlas V, and I'm going stupid on the name of the rocket, it'll have Blue Origin motors on it. And Blue Origin is starting to build rockets themselves that are big enough to do that with. So again, on the commercial resupply contracts, which we just re-upped a bunch of them, we don't really care how that happens. On the Cygnus spacecraft and the Cygnus rocket, they had to quit flying it. Turns out that, well, and we have two rockets that were flying with Russian rocket motors on them. One was the Cygnus and one was the Atlas V. The Atlas V was using new Russian rocket motors, or newly made, let's put it that way, the RD-180s. Turns out that Orbital ATK was buying these engines that were leftovers from the Russian moon program. And they had been told they've been tested and certified, certain things have been done with them, and they had not. They put new engine controllers on them, made sure they fired, and then shipped them to the US. So if you'll recall, there was a Cygnus that got, about 2,000 feet above the pad a couple of years ago and completely let go. And that's when they figured out what was going on. So they, Orbital ATK actually contracted United Space Alliance. Yeah, not United Space Alliance, United Launch Alliance. I'm going way back there. USA ran the shuttle program. They contracted ULA to fly their cargo vessel on top of an Atlas V. So, and from our standpoint, we don't care. Yeah. The Cygnus rocket is re-engined with Aerojet engines, I think, as I recall, and the replacement for the Atlas V is going to have Blue Origin engines on it. So yeah, we're going to quit doing that. Yes, sir.
Does H.265 interest the agency for bit rate reduction?
Okay, question was, does H.265 interest the agency for bit rate reduction? Absolutely. And in fact, for Gateway and for Human Lander, we probably will reject anything that's not at least 265. I don't think, I saw software simulation of what should become 266 at NAB, but I don't think that's going to be ready in time. One of the problems that we've traditionally run into is having to make decisions way early in the programs. And in fact, the core stage external cameras are running 264, and that entire system has been sitting on the shelf to be put on the rocket for over 2 years. So, you know, at certain points, they say, you know, you've got to freeze the design, you have to do this. We're moving so fast on the lunar program that I don't see 265 being a problem. And yeah, we definitely want to see that. When we did the live UHD feed from space, we had to do 264 because of what hardware we could get that we could fly that was compatible with what we could get out of the red camera. But we converted it to 265 on the ground to ship it out to NAB. So. No, those are the AVN encoders. It's I can't remember who makes it. It's a card. It's a PC card encoder. You know. There's a yes and a no to that. Part of what you run into is that when you say you want to run it in software and it's going on part of the space station system or a spacecraft system, now you become part of the critical path of the entire software development program, and everything has to go through all the QA functions. They're a lot happier if we just hand them off an IP stream. Although I'll tell you, there will be no baseband video on the lunar program. Everything, well, what we wanted to do initially was to have our own network on Gateway, feed it to an encoder or two, and then do the downlink that way. And they went, nope, it's all going IP. It's not enough bandwidth for us to do non-compressed anything. So we're putting encoders out at the cameras. There's good and bad to that. You know, when after Columbia happened, we went to the analysis community. Because remember, this was 2003 and 2004 when we were doing this. We said, okay, we're going to upgrade these composite video recording stuff and all this analog junk we've been doing down at Cape to HD. Would you like 720p 60 or 1080p 30? And they went, we want 1080p 60. And went, well, no, you're not listening. Because if you recall, that was kind of the holy grail at that point, and we didn't have it. You want 720p 60, you want 1080p 30. And they said, again, we want 1080p 60. And we said, we're assuming you want 60 more than anything else, so you're getting 720. But, you know, they're fussing because the bandwidth we're getting off the core stage of the SLS rocket, we get 8 megabits for video total. And we got 8 cameras running. Yeah. We will have no more than 2 cameras running at a time live. The core stage of SLS gets up so high. One of the problems we're running, you know, normally the external tank on the shuttle would splash down somewhere in the Indian Ocean. The core stage of SLS is going to go so far, so fast and so high that there was a real concern it was going to come around and smack California. And it will land off the California coast. It's been, you know, but the good part about it is once it's gotten done with 9 minutes worth of powered flight, and they separate from it, we can get telemetry off of it for a while. So what we're going to do is we're going to cycle through the 8 cameras during the launch sequence, during liftoff, and see certain views at certain times, but every camera is being recorded internally. And then once they let go of it, hopefully we don't get too much tumbling out of it, and we'll downlink the entire video of every camera from liftoff till the time that we go through separation. So that's kind of the game plan, but it's all going to be the highest bit rate we're going to get out of anything is about 4 megabits. And it's 264. Optical comm, we're working on it. And in fact, I was on a teleconference Friday where they're talking about coming up with a permanent optical con system from the space station. It's very high speed, but it works really good in space, but a lot of times doesn't work coming back to the ground. Clouds are really messy for optical communications.
You said you use the TFRS right now for the ISS. The optical, what would it use?
Right now, the optical comm, as I understand it, it's going to use a certain select set of ground stations, and it'll be a direct pass. We've done optical comm from the moon. There was an Air Force spacecraft that orbited the moon a couple of years ago that had some NASA components on it. One of it was an optical comm test system. And a picture that yours truly took was transmitted up and brought back. And so they gave us all a poster and said, your picture was, you know, it was a group of us that work on the standards for this stuff. And it was really funny because I was the one that took the picture and I wasn't in it. So. Anyway. Yeah, Bob.
It's entirely appropriate today's Veterans Day because you and Rodney and all of your colleagues, you have brought space exploration to the United States, to the country, and to the world. And I applaud you.
Thank you.